Hello, we're going to be looking at ratio today. Ratio. And this is a way of comparing parts. So it's quite closely linked to fractions and percentages and decimals. And it's in that sort of area, but it's slightly different because with a fraction we say out of a total amount. With a ratio, we just compare parts. For example, in a class, there are 6 boys and 9 girls. We can write that as the ratio 6 to 9. We say this as 6 to 9 with this colon in the middle. And the order matters. So this is saying the ratio of boys first to girls second is 6 to 9. There are 6 boys for every 9 girls. That's the basics of creating a ratio. You compare the parts, put a colon, these 2 dots in the middle. That ratio can also be written as 2 to 3. So we're going to look at some ratios that are the same as each other. And how do we know those two are the same? Well, if we have 6 to 9 here, let's look at the numbers 6 and 9. I know they both divide by 3. This divides by 3, this divides by 3. So, if I divide them both by 3, I get 6 divided by 3 is 2, 9 divided by 3 is 3. So this must be the same as 6 to 9. It's a way of writing it in an equivalent ratio. Equivalent ratio. There we go. And yeah, let's have a look at some more. So let's have a look at some equivalent ratios to 10 to 20. So we need to think what can divide into 10 and 20, but we can also multiply. So let's have a look at some dividing ones. So if I divide both sides by 2, both even numbers, let's do that, we get 5 to 10. 10 divided by 2 is 5, 20 divided by 2 is 10. Those are equivalent, equivalent ratios. I also know that these both divide by 10. If I divide this one by 10 and this one by 10, I get 1 to 2. That is an equivalent ratio to 10 to 20. I could divide it by 5 as well. That's another one. Let's look at some multiplying ones now then. Multiply both sides by 2, and we still get an equivalent ratio. 10 times 2, 20 times 2, 20 to 40, equivalent ratio. And another one. Let's try multiplying by 5. So what's going to happen to this? Let you have a little think. What's this ratio going to become when I multiply by 5? And it becomes 50 to 100. Now you'll notice in all of these ratios, the number on the right is double the number on the left. It's multiplied by 2. And with ratios, these two numbers will always have the same link. They'll always multiply by the same thing. Alright, now we're going to give you a chance to have a go. So let's do a different ratio. I'd like you to see if you can come up with, by dividing and by timesing, a load of equivalent ratios to the following. So, on a piece of paper, put down 8 to 12, and you have 2 minutes to come up with as many equivalent ratios as you can to 8 to 12. Are you ready? Off you go. 2 minutes has begun. What can you divide by? What goes into 8 and 12? What can we multiply by? Alright, if you haven't thought of any yet, try dividing both sides by 2. If you haven't done that one yet, try dividing both sides by 2. What do you get? 45 seconds left to come up with as many ratios as you can. And something to note is that we are looking to do the same thing to both sides. Whatever it is, timesing or dividing, it's going to be fine. 20 seconds left. There we go. So, hopefully you've come up with some ratios. Here's the ones I came up with. You can check if you had these ones, add them to your little diagram if you like. And yeah, basically, as long as you do the same thing to both sides, multiply by the same thing, divide by the same thing, we have equivalent ratios. There's the key language today. Alright, thanks for watching.